So today we will study the rectification type number one, that is half wave rectification, or it's also called half wave rectifier. How does this device work and what are the applications? So we're gonna look into these things. First of all, what is a rectifier? Whensoever we transfer AC current, the alternating current, into the DC current, the direct current. So the device that used to do this thing is called rectifier. However, again we do have a device for transferring the DC into AC as well. That device is known as inverter. I hope that you have heard this word within your home that okay, this is inverter and this is inverter AC and this inverter isn't working. So that inverter is actually performing the transformation of DC current into the AC current. Let me write this thing out as well. It works as an inverter. That is the device inverter that is performing things out there. Then we do have rectifier for AC to DC. So today we'll be learning about the rectifier. How does a rectifier work? First of all, a rectifier, I'm only writing REC. Just keep this in mind, this is the rectifier. It has two types, the basic two types. First one is called half wave rectifier, and then we do have full wave rectifier. Now, what is that wave that we are talking about, half wave or full wave rectifier? So whensoever you create a graph showing up the AC current, so we do have this type of wave. The polarity of the AC current varies from each node. The first, this part from this point to this point is known as a node, and again from this point to this point will be known as second node. So whensoever and current and type of current will change its polarity from positive to negative after each node, that sort of current is known as rectifier. And this thing that we are talking about, that there are two sorts of rectifiers. So there is a rectifier which only rectifies the positive node, that is known as half wave rectifier. And again we do have a second sort of rectifier which rectifies both of the nodes, that one is known as full wave rectifier. Now I've just given an example of half wave rectifier. What does a half wave rectifier do? A half wave rectifier rectifies the wave, but one by one, or what we could say, it actually creates a gap, and it actually creates a node, which is again the graphical representation of the DC becomes pulsating. What is a pulsating? The graph which is created like this, or if I could change my color, so it would be great. So this sort of wave is actually DC current, since the node isn't changing the polarity, but this sort of wave is known as pulsating wave. Pulsating. Why is it a pulsating wave? Because pulse are creating. What is a pulse? I hope that you have seen in most of the films that our heartbeat goes like this. So this up and down sort is known as the pulsate, the pulse. We usually call it pulse. So here, since this node is creating a sort of difference after each part, so we do call it a pulsating wave. However, we do have another kind of wave as well, which is not pulsating but actually a smooth wave. It's actually called a smooth kind of wave. So what a half wave rectifier do? Half wave rectifier is actually make up an pulsating wave. However, the full wave rectifier works on the basis of transforming both of the waves combinedly. So it somehow created less pulsating wire. It actually creates a sort of complete node at once. And if you're not getting my point, or if you're not getting what I'm trying to say, so we'll decide and we'll discuss it in detail during the lecture. So let's get started. What is an half wave rectifier? As I have told you each and everything about what is a wave, what is a pulsating wave, and what is a rectifier. So let's first make few things. If you have gone through my previous lecture, so I hope that you know about P-N junction, what is P type, what is N type of semiconductor I have told in my previous lectures. So to create an half wave rectifier device, first we need to attach an diode, and diode is a p-n junction device where the p junction and n junction is placed. This p junction works as an anode while the n junction works as a cathode, and we all know anode is a negative sign and cathode is a positive sign. However, after this one we do have a resistor, or what we could say is our load, which we use to actually calculate the current. Then we do have ground. Ground is actually the zero voltage where the voltage becomes zero. So this is a device which is used to do half wave rectification. So let's first get started. Let's draw and wave. Let's create it from the base. Okay, let's just consider the positive side of the wave first. So just suppose that we are providing positive 5 volt to this device to be actually for calculation. We all know that at initial the negative sign will attract this positive sign. However, the positive attraction or repulsion depends upon the charge on the n side. So the charge on the n side so far is what? Only 0 volt, since none of the current is actually flowing from here. So this is 0. Now tell me this thing, will positive 5 volt get attracted to the positive 0 volt? On the number line, positive 5 volt is greater than the 0 volt. Again, the positive 5 volt will get attracted towards the negative pole of the diode. In this sense, the current will flow because of the attraction. Here, because of being the greater number, 0 volt will act as a negative part and this one will act as a positive part. So positive is attracted towards the negative, so we get the current flow, or this is also known as forward biasing. I have told about the forward biasing and reverse biasing in my lectures before. So you can go through those lectures so you'll get an idea what is forward biasing. Well, for now you just need to keep this in mind that the process that I did is known as forward biasing, and forward biasing is a process in which the current flows. We also consider it as, just a minute, current flows. We also consider it as a closed circuit since the current is flowing. So we consider it as a closed circuit. And now let's create the wave. Okay, first we need to do the negative side as well. Now this was the positive half cycle of the current. Now let's do for the negative half cycle. The process would be the same, but the only change that will occur in the whole process would be in the charge of the voltage. So now the voltage will become negative. Now tell me one thing. Negative 5 is greater than 0 or less than 0? Well, the -5 is less than 0. So in this case, this will actually act as negative side and this will attract as the positive side. And here we know that the P junction is also negative. So negative and negative will not attract each other. In this case, none of the current will be accepted. So this process is known as reverse biasing. Reverse biasing. Because of this reverse biasing, there would be no current that will flow. Since the electrons are not getting attracted, so no current will flow simply. Now again, these sort of biasing, these sort of process or the negative cycle of this biasing will considered as the open circuit. This device will become an open circuit in this case. Well, one thing that I maybe forgot to mention, how to showcase an open circuit or closed circuit. Open circuit is always showcased as this thing, while the closed circuit is showcased by this symbol. Let me write it. This is for the open circuit and this is for the closed circuit. Back to the topic. Now let's create the graphical representation of this biasing, of this half wave rectification. Now let's see, does polarity change still or we get a direct current? Let's create a graph. First of all, x-axis and y-axis in action. Then, first what we did, this is a AC current that we are providing. Now after rectification, first of all, the positive side will come. So because of the positive side the current flows, so we make a anode or a positive polarity side. Then does the current was conducted when the negative cycle was gone through the rectification? Well, in that case, we didn't got any current. Again, in the positive cycle, the current will be conducted and negative cycle it won't. So in this case, we get a DC current, but this is a pulsating DC current. There is a gap in between the flow of current. Well, this is not the part of topic, but whensoever we want to actually change the pulsating wave into the smooth wave, so we use the capacitor for that thing. Well, this is a huge and really different topic, but in case if you have been asked that how do we convert a pulsating wave of DC current into a smooth wave, so you can mention this thing. And this was all for today's lecture. Thank you so much for watching and stay tuned for future videos.